Good day, everyone. The topic for today is about polynomials. And in this session, we are to discuss the basic terms, how to add and subtract polynomials, as well as the grouping symbol. Let's first proceed to the definition of polynomials. Polynomial is an algebraic expression which can be a constant, a variable, or a combination of variable and constants involving a finite number of fundamental operations in algebra. In example, addition, subtraction, multiplication, division, exponentiation, and extraction of roots. There are a bunch of examples for polynomials, and here are just some of it. We have 5m cubed n p over q, 6p x plus 17, 2y minus 5, and etc. And for you guys to fully understand what polynomials are, here are the basic terms that we use. First is the constant. It is a symbol that assumes one specific value. And as you all know, constant is just basically the number itself. So we have your examples 8, 38, 17, and any number that you could think of. So that is considered a constant. Next is variable. Variable is a symbol that assumes many values and it is any letter in the alphabet. Examples, we have A, B, up to Z. So that is the variable. So it's the letters. Third one is the term. Term is an expression preceded by a plus or minus sign and involves two or more factors. Examples, 5m cubed n, p minus 3q, and 2 over x plus 9b minus 4. 5m cubed n here is only a single term, while p minus 3q here, while the expression p minus 3q here has two terms. First term is p and the second term is 3q. And for the last example, we have three terms here. First term is the 2 over x, second term 9b, and the third term is 4. And later on, I'll discuss what is the name if the polynomial has only one term, what is the name if it has two terms, and for three terms. Let's now proceed to the fourth one, which is the numerical coefficient. It is the constant factor of the term. Example, 6p raised to 4q and 5mn cubed. So the numerical coefficient here are 6 and 5. So just remember that the numerical coefficient is the constant factor of the given term. Next is the literal coefficient. It is a factor representing variable of a term. In the example, 6p raised to 4q and 5mn cubed. Earlier, we have mentioned that 6 and 5 here is the numerical coefficient. So, p raised to 4q and mn cubed is called the literal coefficient. Next is the monomial. Monomial is a term involving only the product of real number and variables with non-negative integral exponents. Example, we have 9x squared y, negative 6mcb, and z. So to make it easier for you to understand, monomial consists of just one or single term only. So all the single terms here, so that's a single term, this is a single term, so those are called monomials. Seventh, we have the binomial. It is a polynomial consisting of exactly two terms. Examples, p plus 16 and u minus v. So we have here two terms. First term is p, second term is 16. So for the example, p plus 16, it is a binomial because it has two terms. In the example, u minus v, this has two terms. First term is u, second term is v. So that is called a binomial. So binomial, from the word bi, it has exactly two terms. Next is the trinomial. It is a polynomial consisting of exactly three terms. We have here some examples. m minus 4r plus 1. So in this example, we have three terms. First term is m, second term is 4, third term is 1. And in the example, t squared minus 2t plus 1. So this is a trinomial. First term is t squared, second term is 2t, and third term is 1. Next, we have polynomial. It is a sum or difference of infinite number of monomials. Example, a cubed plus 5a squared minus 7a minus 1. So given this definition of polynomial, we can call any monomial, binomial, or trinomial a polynomial. So those three are under the name polynomial. Next, if there are two monomials or two terms that have the same literal coefficients, they are called the similar terms or like terms. Otherwise, the terms are dissimilar or unlike. Examples of similar terms, we have 4BD and negative 6BD and 4AC and 7CA. So regardless of the order of the literal coefficients, so long as they are the same, then it is called similar or like terms. Then we have the dissimilar terms, 11PQ and 11P squared Q and 17XY and 2ZY. Why do you think 11PQ and 11P squared Q is a dissimilar term, though they have same variable used, which are P and Q? Okay, it is because the variables P here have the different degree of exponents. So that's why they are dissimilar. And lastly, the degree of the polynomial is the greatest exponent occurring in the variable. Example, 5m raised to 4 minus 30m squared plus 8m minus 1. The degree of polynomial here is 4. Next, in the example, 11p squared minus 2p plus 30, the degree of the polynomial is 2. Since it is the greatest exponent occurring in the variable. And lastly, 2c. So the degree of the polynomial here is 1 because 1 is the greatest exponent occurring in this given polynomial. So if you're asked for the degree of the polynomial, so just look at the greatest exponent occurring in the given variables of the polynomial.